Other networks, they say like Skype, it looks like Skype, right? So all you have to do is classify the traffic as Skype. And if you don't blend in as something else, then they can block it or tamper with it or inject data or do something nasty to it. So what we tried to do was make it so that that wasn't possible. Because if you block SSL with Firefox talking to an Apache server, you take down a huge portion of the internet, right? Lots of valid e-commerce that has nothing to do with blocking is going to be stopped. And that is actually damaging to an economy. So they can't, I believe, in most cases, just block everything. There are some companies, I think Fortinet, they sold a firewall to the Burmese government, and they're like arms dealers, right? They're selling weapons to people to try to win over the hearts and minds of people, in a way. And they do it by force, right? Because they log these things, they visit people in their houses, and they sell these essentially these weapons of filtering technologies to oppressive governments like the Burmese, I think. And those places actually try to man in the middle all SSL connections, right? So every time you go to any website, you get an SSL warning, right? So in places like that, bridges might not be the most effective strategy because they have a scorched earth policy. They don't care about anything at all except for extreme control. But in a place like China and in a place like Iran, even that is not happening. But there are some places. I bet if you were in North Korea, we've never met a Tor user from North Korea. But I bet if you were there, you would have, if you had internet access at all, you might find yourself in a situation where using Tor is illegal. But even if it was possible for you to use it, technically they might just try to block access to everything except for like, you know, the North Korean government website. So you kind of have access to the internet, but not really. But if you have access, then you can connect to a random person, and that random person can help you and provide you with certain security properties that you'd like. And of course, if you're running one of these Tor servers, you're going to probably notice that you generate traffic that might be interesting. So like, someone could use your Tor server to do something bad, right? They could use it to report a human rights violation to a website. The website could be forced to turn over their logs, and then the logs track back to the person that's running the Tor server. So all 50 of you or 100 of you that raised your hands and said you're going to go home and run Tor servers, right? Yeah, so you could be the person whose IP address is found in the log. And so as a result of that, we think that it's extremely important to talk to law enforcement. We did this in Germany. In Germany, there were people whose houses were getting raided by the police, right? Real Gestapo-like tactics, coming in the middle of the night, threatening them. So we taught police officers that an IP address is not the same as a fingerprint, right? We said, if you find an IP address, it's a good lead, but it does not necessarily mean that it is the person whose house you visited. They might have an open wireless network. They might have a Tor server. There are still possibilities that police around the world don't know about this. It's in fact a certainty, right? I'm guessing that the Jordanian police, if they found an IP address, they might think that it's you. And in Egypt, for example, you're actually responsible if your IP address is found in a log file. So it's probably really unsafe to run a Tor server in a place like Egypt. I know some people that are doing it now, and they're very brave, but I wouldn't advocate that because it doesn't seem like the law is on their side. In the United States, I run a bunch of Tor servers, and I'm totally ready if the police want to come and ask me about them. I'll tell them all about Tor. And I do not think they would win in a court of law if they tried to arrest me for helping people that are accessing blocked content, for helping people that are in Iran trying to Twitter or Facebook about an uprising that they wish to start, for example. Or in China, where they're trying to read about the past as it actually happened. I just don't think that would fly, right? I don't think legally the US would be able to suppress my ability to run that server. But here in Jordan, that might not be the case. And so I would love to talk with lawyers here to get a good idea. And I'd be also happy to talk to police here to give them an idea that an IP address is not you. Because it's really important that the police learn this. Because if they don't learn it, you'll have people that look like they are essentially criminals when in fact they're not, for simple things. And it's really important that that's not taken as like a proof. You know, a proof of a crime or proof of identity in some way. And it goes hand in hand with Tor. So we see a lot less of this stuff happening in Germany, for example, because the police there know about it. And in fact, the German police use Tor at times. And so that to me is, I think, in a sense, a very good aspect that can come out of talking to the police. So that said, that's my last slide for this talk. I have a different lecture I can give, if you want, about circumvention solutions. Because I just talked about TOR for this whole time. But in general, TOR might not be what you need. Right? You might want something that is a little bit faster for, say, uploading like gigabytes of videos, or you might not want anonymity properties, or you might want something that just isn't TOR, and you want to know how to like verify that. And so I have some slides. About that as well, if that's interesting. But I've also been talking for a really long time, and I'd love to like pass the microphone around, or if we have a second microphone, to give it out, and then we can do some questions and answers, because I see some of you look like you're falling asleep, and then others that look like you have some questions. So thank you, by the way. Yeah, you have a question?
Yeah, actually, in practice, how can we use it? We have to connect to the server. I think there is a Firefox add-on.
Right. So from a practical perspective, the question is, okay, sounds great, how do we use it? You need to go to the TOR project website, or you need to email gettor@torproject.org. And you need to download a piece of software called TOR. There's a bundle, the Vidalia bundle. It gives you a nice little graphical user interface to control TOR. So you can say, I want a new identity, and it'll build new circuits for you. It'll pick a different three relays in the set, right? And I didn't mention this before, but the way that TOR actually decides how, I mentioned partially, but the way that TOR actually decides which path it's going to take through the network is based on a policy of the last server, and then you randomly choose these servers based on a set of constraints. So in order to break the security of TOR, you have to either break by watching the entire network, or you have to be watching the 3 servers that you choose. So if you choose k of n servers, where k is 3 and n is 2000, that means that to effectively break it, you really need to watch a lot of the traffic, probably all of them, because you don't actually know which server you're going to be talking to. And so trying to attack that requires that you have like basically guessed those 3, or you watch it all. So TOR makes this like really easy for you, because you could use like a switch proxy or something like this to like rotate through 2000 servers just as one hop. But that doesn't give you the properties that you want with three hop proxies where there's crypto, between these different points. So the TOR program itself will take care of that for you. It makes the choices for you in the most intelligent way. You can restrict it. You can say, I never want to use a TOR server in America. No problem. You probably shouldn't do that, but you could if you wanted to. You can say that you exclude those servers. So you run the TOR program, and if you want to use a web browser with it, you use a program called TOR button, and you use it with Firefox. And it protects you against a lot of application-level attacks, JavaScript that will try to de-anonymize you by getting your computer's actual IP address, or a Flash application that will get your real IP address, or bypass a proxy setting, or a Java applet. And so it tries to protect you against a bunch of different attacks. And that's really useful. And you cannot safely browse the web without TOR button or something like TOR button when used with Firefox. So like using Opera and TOR together is probably not safe, because it could leak DNS packets that will reveal the location of where you're going, right? If someone's watching you locally and you ask for Al Jazeera, geez, they don't have to break TOR to know you're going to Al Jazeera, right? And unless you're just like intentionally trying to incriminate yourself to like mislead them, which seems unlikely. So you have to make sure the software is really tested to not be leaky, as we often call software leaky, because it'll leak a DNS request, or it'll maybe not make a TCP connection through. And so TOR and Firefox and TOR button together make web browsing anonymously possible.